Now let us look at finding out whether the following questions given are true or false. In fact, this true or false questions will help us in understanding and implementing what we have read so far. So let us start with the first question. The first question is as follows. The first question is, in an analog signal, both the magnitude of the signal and the independent variable are continuous. Okay, in analog signal, both the magnitude of the signal and the independent variable are continuous. So we have to tell whether this is true or false. Earlier we have seen that analog signal definition we have given that the magnitude of the signal and the independent variable are continuous. Okay, so this must be a true. So let us see whether it is true or false. The answer is true, because if it is a continuous time signal, the magnitude and the time of the signal will vary continuously. So this is a continuous time signal. So we are saying it is a true. Okay. Now let us look at the second question. Complex exponential signal is a three-dimensional signal. A complex exponential signal is a three-dimensional signal. The answer is true. Let us look at the third question. The third question says the sync signal is a periodic signal. What is the formula for verifying whether a signal is continuous or not? That means x of t plus t, capital T, must be equal to x of t. Then it is a periodic signal. So let us see if sync signal is a periodic signal or not. As we have also seen earlier, this is false. So sync signal is not a periodic signal. It is a non-periodic or a periodic signal. So our answer is false. Okay, if you see the sync signal diagram, sync signals look like this. Okay, there are some crossover points here, isn't it? So this sync signal is a non-periodic signal. Now let us look at the fourth question. The fourth question says the sinusoidal and complex exponential signals are always periodic. The sinusoidal signal and an exponential signal. Okay, we have seen what a sinusoidal signal is. A sinusoidal signal is like this. Okay, this is equal amplitude and this certain time period. Okay, similarly, you have an exponential signal, okay, or it can be a signal which is falling. Okay, exponentially rising signal or exponentially decay signal. So are these periodic? That's what the question says. What is the question? The question says the sinusoidal and complex exponential signals are always periodic. Okay, the answer is true. So a sinusoidal signal and a complex exponential signal are always periodic in nature. The question number 5 is as follows. The product of two odd signals will be an odd signal. Let us take two odd signals, okay, and if we multiply them or we find a product of these two odd signals, the resultant signal is also odd, as was the question number 5 says. Is it true or false? Okay, we all know what is an even signal condition and an odd signal condition, isn't it? So from that we have to also further go and analyze. If I multiply two odd signals, then the result is also an odd signal. Of course, if I multiply two odd signals, the result is not an odd signal. So it is a false answer. So the answer is false. So if I multiply two odd signals, let us say signal 1 and signal 2, if I multiply this is odd and this is odd. Okay, I am taking a product here. The resultant is not equal to an odd signal. Okay, so the answer is false. Question number 6 is, when the energy of a signal is finite, then the power will be infinite. Okay, we're talking about two types of signals. We said energy signal and a power signal, and when we talk about energy of a signal, if it is finite, then the power will also be infinite. That means energy is here, this is finite, whereas power is infinite. Okay, is this valid for a signal? We have to find out whether this is a statement which is true or false. The statement is false. Okay, when the power is infinite, the energy is 0 and vice versa. So we cannot say that energy is infinite and then power is infinite. So the answer is false. Question number 7 is, when the power of a signal is finite, then the energy will be 0. Again, a little bit tricky question. Let us compare this with the earlier question 6. The question says what we said? We said power is infinite and we said the energy is finite. Now let us see here. 7th question says, when the power of a signal is finite, then the energy will be 0. This again is false. Okay. When the energy is 0, power must be infinite. So that's the condition. So 7th question, the answer is again false. What is true? If the energy is 0, then the power must be infinite for a signal to be classified as a power signal. So this is a false answer. Let us look at the 8th question. What does the 8th question say? It says the causal signals are defined for all values of t. Okay, for all values of t, causal signals are defined. Is this true or false? This again is a false statement because we said the causal systems are dependent on the past and the present and they do not have any prediction of the future. When I say for all t, we are considering also the future. So whatever past and the present signal, then it is called a causal signal. As we are talking about the signal being defined for all values of t, we say this is not a causal signal. So the answer is definitely false. Now let us see the question number 9. Time shift of a signal x of t is obtained by replacing t by t plus or minus m. Okay, so this is the true answer. So what is the time shifting you mean? Well, either is shifted to the right or shifted to the left. For example, a signal is there like this. Let us say this is t and I have a signal here. I can either shift this direction or I can shift this direction. So when I say time shifting, let us say now the same signal is existing at t plus with a certain value and here I can also shift it by a certain value here. Okay. Now we are just talking about the shift. We are not talking about the equation here. So we are saying that now t plus m. That means let us say this is 2 nanoseconds shifted like this. This becomes like this, or it can be shifted 2 nanoseconds like this. It can be like this also. Or it can be the same axis. It can be here also, or it can be here also. Depends upon this. So this is basically a time shifting. The answer is true. Now let us look at the question number 10. The rate of change of a signal is called differentiation. Yes. It is a correct answer because differentiation means what? D by dt. So whatever changes, this differentiation itself, the indication d by dt is an indication that the rate of change of time with respect to time is called as a differentiation. So the answer is true. Question number 11. An impulse signal is infinite magnitude but constant area. The answer is true. Whenever you draw an impulse signal, we always indicate, let us say the signal exists at t is equal to 0. So you always indicate by an arrow. The arrow towards the top indicates that its magnitude is infinite, whereas the area of this signal always remains constant. So the answer is true. 12th question. A system which satisfies the property of linearity and time invariance is called as an LTI system. Linear time invariant. A system which satisfies the property of linearity and time invariance is called as a linear time invariant system. That is in fact true, isn't it? So LTI itself indicates the linear plus time invariant. That means it satisfies both the properties of linearity. The linearity means what? Both homogeneity and superposition must be satisfied. Plus the output should not be dependent on time. If there is a shift in the input time, the output also will be shifted with the same. Whereas the signal essentially remains constant. So it is time invariance. So LTI system is defined by this. So the answer of course is true. Now question number 13. Let us see the question. For a constant coefficient differential equation, the homogeneous solution will always be exponential. So let us reread the question again for clarity. So let us understand what the question says. The question says, for a constant coefficient differential equation, the homogeneous solution will always be exponential. So that is a true answer. The question number 14. For a constant coefficient differential equation, the particular solution and the input will be the same type of signal. Okay, so this again is true. So when you look at a constant coefficient differential equation, the particular solution, the PI, and the input will be of the same type of the signal. So this is a true answer. Let us look at the question number 15. The systems that require memory are called dynamic systems. Okay, as we have seen earlier, the classification systems. So we have to recollect what we have studied earlier and then answer this question. The answer is true, because any system that requires memory is called as a dynamic system. The system which doesn't need to depend on memory is called as a static system. The answer for the 15th question is true. The systems that require memory are called as dynamic systems. So it is a true. Let us see question number 16. In a time invariant system, if a delay is introduced either at input or output, then the overall response will remain same. So we are talking about time invariant system, and we are talking about delay which is introduced either the input or the output, and we are saying that the overall response will essentially remain same, which is a true, isn't it? Because that's what is the property of time invariance. So even if there is a delay introduced in the input to the output, the overall response essentially remains same. So this is one of the characteristics that actually define the time invariance of a system. So the answer for the question number 16 is true. Now let us look at the 17th question in true or false. The 17th question is, a non-linear system is one which satisfies the principles of superposition. So I think you all understand the answer. The question is, a non-linear system is one which satisfies the principle of superposition. We have seen earlier that the linearity property, one of the important conditions to be met for a system to be linear is superposition. But we are talking about a non-linear system, so answer is definitely false. So a non-linear system will never satisfy superposition principle. If a system satisfies superposition principle, it is called as a linear system and not nonlinear system. So the answer is false. 18th question. The non-causal systems can be realized in real time. Non-causal systems can be realized in real time. So we already, when we spoke about causal systems, we said real-time systems are all causal, and anything which is not real except for some conditions cannot satisfy causalities. That means they are non-causal. So that means if the system is real-time, it must be causal and not non-causal. So this question says non-causal systems can be realized in real time. That's what it says. So we cannot realize them in real time. So the answer is false. Now the question number 19. The question number 19 is, the response of a non-causal system depends only on the past inputs. The answer is of course definitely false, because when we said a causal system is the one that depends on the past inputs plus also whatever is the present value. The present value is defined by the past values. That's a causal system. A non-causal system is of course does not only depend on the past inputs, isn't it? So it is a false answer. The question 19 is false. Question number 20. All LTI systems are BI/BO stable. All linear time invariant systems are bounded input, bounded output stable. This is again false, because not necessarily. This is not universally satisfactory condition. So the answer is false. 21st question. The stability of non-LTI systems can be tested by using its impulse response. The stability of non-LTI systems can be tested by using its impulse response. Yes, the answer is false. Non-LTI systems cannot be tested using impulse response. LTI systems only are testable using impulse response. So the answer is false. 22nd question. The non-feedback system depends on past inputs. The non-feedback system depends on the past inputs. So this is a true answer. That is, systems without feedback depend on past inputs also. Okay, systems with feedback depend on the present also, because the present, the output present response is fed back to the input. So that's a feedback system. Now 23rd question. Convolution is a linear process. It's not linear process, it is a non-linear process. So the convolution is not linear. So the answer is false. 23rd is a false question. The convolution can be used to determine the response of non-LTI systems. If you remember what we have studied earlier, does this answer correct or false? The answer is false, because we never spoke about non-LTI systems and convolution together. We said a system output is a convolution of the input and the transfer function of the system. So y of t, if you call y of t as the output response of a system, it will be equal to x of t, which is the input of the system, convolved with the transfer function of the system h of t. That is, y of t will be x of t, h of t. Whereas this question says the convolution can be used to determine the response of a non-LTI system. So the answer is false. Now the 25th question. The convolution operation satisfies the commutative property. True. When we have studied about the convolution different properties, we also found that the commutative property is in fact satisfied by the convolution operation. So the answer is true.